Hi everyone, in this tutorial we are going to talk about conformational isomers, also known as conformers. Okay, these are stereoisomers that have the same configurations in terms of looking at their R and S if present, but how they're going to differ is that the groups are going to be interacting differently in 3D space. Now you can think about this as being a difference in steric interactions. That's how I personally think about it, okay? The configurations are the same between the two compounds at any asymmetric centers, but the groups themselves will be interacting with each other differently in 3D space. It's very important to understand that these are stereoisomers that can interconvert, okay? They are capable of interconverting, either because we are looking at chair flips, okay, chair conformations are conformational isomers, or we can look at conformational isomerism being the result of rotation about single bonds, such as in these examples here, there's rotation about a carbon-carbon bond, and that's what's making them conformational isomers. And then on the far right, we have an example where we've rotated about a carbon-carbon bond in a Newman projection, and we have conformational isomers. Let's look at these examples. This first example shows that the configurations are the same between these two structures. They have the same constitution, and they are the same configurationally. But notice what's different is the conformation. In the structure, you have the bromine axial interacting 1,3 diaxially with those hydrogens that are also 1,3 and axial. In the chair flip, these are chair flips of each other. In the chair flip, the bromine is equatorial, no longer having those steric interactions. And the ethyl group is now in the axial position, participating in 1,3 diaxials. Whereas in the left structure, it was equatorial, and it wasn't possessing those 1,3 diaxials. These are conformational isomers. They have the same configuration, but there's different steric interactions present between the two structures. In the middle example, all that we've done between the two structures is a rotation. We've rotated around clockwise. We rotated the methyl to where the hydrogen is, the hydrogen to where the chlorine is, and we rotated the chlorine to where the methyl is. I've proved that these have the same configurations ahead of time, and we're keeping this carbon stationary, but we're rotating around our groups here. And as a result, these are conformational isomers. You would have different gauche interactions if you were to look at these structures in the Newman projection, okay? They are configurationally identical, but the steric interactions, if you were to look at it in the Newman, would be different. In our last example here, we have two Newman projection structures, okay? And I've proved that the front and the back carbons have the same configuration, so they can't be another type of stereoisomer like an enantiomer or a diastereomer. These will be conformational isomers. Check this out. If we looked at the steric interactions, you have a bromine methyl gauche interaction and a methyl OCH3 gauche interaction. We've rotated both the front and the back carbons between the two structures. And notice how now there's a methyl-methyl gauche, a methyl OCH3 gauche, and a bromine OCH3 gauche. Okay? Therefore, we have stereoisomerism, these conformational isomers, as a result of rotation about the front and the back carbon. But configurationally, again, I'm stressing this, configurationally, the two structures are identical, the same R and S. Okay? So conformational isomers are considered stereoisomers because the groups are interacting differently with each other in 3D space, okay? Attached to the same carbons, same constitution, but we kind of consider them to be different steric states. They are conformers of each other. Stereoisomers that interconvert either in the context of chair flipping, right, chair flips, or because of rotation about single bonds. And we then have groups experiencing each other differently, having different anti and gauche relationships.